classes tomorrow then too, tell them they can come sign up.
Hi, welcome to video number 5 for the summer work. First thing we're going to start with is some vocab. And previous students will tell you that this vocab goes through the whole year. So super important. The first vocab word for today is the name of the class, which is statistic. Statistic is a number associated with a sample. So it's a number that you get from taking a sample, and it varies from sample to sample. A parameter is a number associated with a population. Typically, you will not have the parameter unless your population is very small and you're able to ask or measure everything in your population. But in statistics, usually you get a number from the sample and use that to estimate your number for the population. The parameter is always constant because you're able to get information from everyone. One of the things that I do to help me remember which is I say that statistics starts with S and sample starts with S and parameter starts with P and population starts with P. So sample, statistic, population, parameter. Resistant is our last vocabulary word. That is a statistic. So a number from a sample that is not sensitive to extreme values. Okay, let's translate that a little bit. We've got some big words. Sensitive means not easily changed. And extreme values refers to skew or outliers. So resistant means a statistic that is not easily changed by skew or outliers. It kind of holds its position even if you've got extreme values. And to compare resistance, we're going to talk about two measures of center. So back in video 3, we talked about SOCS, SOCS, shape, outliers, center, spread. And we're still refining what we're going to put for SOCS for our distributions. And mean and median are two measures of center. And we're going to talk about whether or not those are resistant. Go ahead and pause so you can set up your notebook like mine. I researched and found the birth rates of 10 sampled countries. So notice this is not all countries. This is sampled countries, which means these are only 10 out of a lot of countries. And that's going to change our measure of spread later. And birth rate is defined as births per woman. So in this particular country, there was 2.58 babies born to every woman on average. This country was Malaysia, actually. The first thing I want to show you is we're going to talk about how to calculate the mean and how to calculate the median. And to calculate the median, It's much easier to do that if your numbers are sorted from least to greatest. So the first thing I'm going to show you is kind of a life hack, which is called sort A. And sort A means ascending order. And to sort your numbers in ascending order, the first thing you do is hit the stat button and then enter over edit. And I already have mine in here, but if you do not have yours in here, you type them in. Let's just check them. $6.89, man, that's a lot of kids. Okay, just checking my numbers out. And to sort my list in ascending order, to change it, go to stat, and then instead of hitting enter on edit, scroll down to sort ascending. Notice there's also an option for sorting in descending order, and hit enter. And the calculator is going to say, what would you like me to sort? And you would like it to sort L1. L1 is located right above the 1 on your calculator. So hit second 1. And it pastes in the list L1 for you. It's going to be anticlimactic. You're going to hit enter and it's going to tell you it's done. It doesn't give you the numbers here. However, when you go back to stat edit, the numbers are now sorted in ascending order. This makes it a lot easier to both make a histogram and to calculate your median and any other statistics that you need from your data set. So let's write these down in ascending order. Okay. 10 numbers, 10 numbers. All right, the first thing we're going to do is calculate the mean. And the mean is also called the average. And because you're working with a sample of 10 countries, the symbol that you use is X with a little line over the top. And this is called X bar. And to calculate X bar, you add all of the numbers and divide it by how many there are. In this particular case, you have 10 numbers, and College Board doesn't require you to show all 10 numbers in your calculation. You can get away with showing the first two plus dot, 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 plus the last one. So 1.33 plus 1.42 plus dot, dot, dot plus 6.89 over 10 numbers. And this is just to write it down on your paper, but of course you have to type all of the numbers in the calculator to do the mean. So we're going to add all of the numbers together, 1.33 plus 1.42 plus 1.7781. Okay, and I get 25.28 on the top, divided by 10. And we're going to round that to 2.53. and be very careful to add our units. I'm sure that all of you coming into this video probably knew how to find the average of some numbers, but the median is a little bit more difficult depending on how many numbers you have in your data set. I picked this set specifically because it has 10 numbers. So I'm going to write down here before I start that there are 10 numbers in this data set, and that's going to determine how I find the median. So I have 10 numbers, and the median's definition is the middle number. The middle number doesn't really exist in my data set. It comes between 1.84 and 1.97. So I like to take some kind of other color, some kind of note about where that median would be. I like to show 5 numbers below, 5 numbers above. Because there are 10 numbers, it will be the average of the 5th and 6th number. In this case, 1.84 plus 1.97 divided by 2, which is 1.91 births per woman. And as I said, finding the median is a little different depending on your data set. And later on in the video, I have a couple of other data sets that I'm just going to have you watch me demo how to find the median, the quartiles, and the interquartile range, depending on how many numbers there are. But for now, we're just going to go with this 10 number data set for the moment. The next thing we're going to do is work on describing the distribution for this data set. And we're going to start that by making a histogram. And we worked on histograms in video 4. So we talked a lot about the bins and the appropriate way to label frequency on the height, label your x-axis always. And if a number falls directly on one of the bins, it always goes into the higher one. We have a lot of decimals here, so I don't think that we're going to have any trouble in this particular example because none of our decimals look like they're going to fall on any of the whole number of bins, which is great. But let's count. So I don't have any values between 0 and 1. And between 1 and 1.9 repeating, I have 1, 2, 3, 4, 5, 6 values. Between 2 and 2.9 repeating, I have 2 values. Between 3 and 3.9 repeating, I have 1 value. And I don't have any values in the 4s. I don't have any values in the 5s, but I have this value 6.89, which is between 6 and 6.9 repeating. And you might be saying to yourself, that might be an outlier. That looks like an outlier. And it does look like an outlier. Soon, I'm going to teach you a process how to determine if that's an outlier for sure. But right now we're working on mean versus median. And I want to talk about the relationship between these two numbers and the shape of the graph. So first, I have given us a spot at the bottom of the page to write soft. Oh, more management. Okay. And the shape of this distribution, so notice that the tail is going to the right. So this shape is right skewed. So remember, like you're pulling on the graph to the right, that makes it right skewed. And for now, hopefully you're thinking in your head, I bet that one is an outlier. And I have to say, being a mom, that thinking about having 7 kids or close to 7 kids is kind of overwhelming. So I'm thinking that probably is an outlier. What country is that? Niger. Anyway, so for now, before we know our process, we're going to say possible outlier at 6.89. I'm going to come back to this later after we talk about outliers and to see if we can confirm if that's an outlier or not. There's a very specific process that we use to determine whether or not something's an outlier. So prepare for that. But for now, we're going to say possible outlier. And center is kind of what I'm interested in right now because we just talked about 2 measures of center. There's also a third measure of center that we don't use very often called the mode. The mode is the value that occurs the most. In this case, there are no repeats. So you don't really have a mode of your data set, but you do have a mode of your graph, which is 6 tall and between 1 and 2. That's not really helpful for us here. We don't really refer to the mode unless it's your only option. So your choices in this case are mean versus median. And what I want to do is I want to take my red pen that I was using a second ago. I want to mark the mean and the median on this histogram so you could see both and the effect of the 6.89 in your data set, because this is really the one that's making a lot of difference in the numbers. Notice in the mean calculation, the 6.89 is included in the calculation. In the median, it's the first thing to get crossed off. So it's not used in the calculation. It doesn't actually matter if it's there. So coming back to these 2 values, I have the mean is 2.53. So I'm just going to do my best here. 2.5-ish. Label X bar right there. And then the median is 1.91, which is going to be about here. Notice that the mean is above the median. It's greater than the median. And that's because in the mean calculation, you use the outlier, possible outlier of 6.89. And so we call this being pulled into the tail. The mean is pulled into the tail because you use those extreme values in calculating it. And we want to refer back to the vocab word that we learned at the beginning, resistant, a statistic that is not sensitive to extreme values. The mean is sensitive to extreme values because you use the extreme values in the calculation. The median is not because it just got crossed out when I came into the median. So I want to write a note here. The mean is not resistant and is pulled into the, I need my, hey, I made it pretty far without needing whiteout. Nice. And is pulled into the tail. When skew or outliers are present, choose median as the measure of center. Okay, so do we have a skew in this graph? Yep. Do we have a possible outlier in this graph? Yep. And either one of those would qualify us to use the median. So for center, I'm going to state the median is 1.91 births per woman. Notice that I'm including the units. And I'm choosing the median because there is a skew or outlier. In this case, it looks like there's both. For spread, I'm going to hold on that because the only spread that I've taught you so far back in our previous videos has been range. And range is not the best measure of spread. So I'm just going to leave this until we talk more about spread in our next part of our video, which I believe is video 6. Okay. So flip your page. Oh, nope. It's in 5 minutes from now, 2 minutes from now. Effect of skew or outliers on measure of center. Okay, so these are the rules that you want to follow on which one to choose. If the shape is roughly symmetric with no outliers, the mean and median will be similar. Meaning when you calculate the mean and you calculate the median, the numbers will be very close to each other. In that case, you want to choose the mean. Why? Because the mean is more widely published than the median. If the shape is skewed or has outliers, choose median. If the shape is skewed or has outliers, the mean will be pulled into the direction of the tail, which means that it is not resistant. Okay, so there's your 3 different possibilities for center. Again, mode you're not going to use very often. It's not super helpful, especially when you have a data set like the one we worked on where there were not any repeats at all. Mean versus median. You want to choose the mean when it's roughly symmetric with no outliers at all. If it looks pretty even on both sides. The mean and median, in that case, will be very close to each other. And you should note, sometimes they won't give you a graph. Sometimes they will just give you the statistics from the data set. You can tell what shape it is from the relationship between the mean and the median. If the mean and median are close to each other, that means it's symmetric. If the mean is above the median, that means that the tail is going above to the right. If the mean is below the median, that means the tail is going below to the left. Okay, so now we're going to talk about spread, and we're going to have the challenging moment of calculating standard deviation by hand. I'm going to mentally prepare you that this is a little bit of a tedious process. In the next video, video 6, I am going to show you how to do this on the calculator. And I will not ask you to do this by hand very often, but I do need you to know how it works. So the first measure of spread that we talk about is range. Again, range isn't super helpful. Sometimes it's all you have, especially if you have a histogram. A lot of times the only thing you can do is kind of take the top minus the bottom. But the important thing here to note is that range is not a range. Range is a number. Range is the max number minus the min number. And as you can imagine, it is not resistant to skew or outliers because the max and the min might be outliers. And since you're using them in the calculation, it's definitely not resistant, which makes it not a great measure of spread. Again, sometimes you have no choice. You have to use it. When you're talking about range, do not say the low to the high like you would a range of numbers. In stats, you subtract and get a number. So for our previous example, the birth rates, the max was 6.89. The min was 1.33. So my range is 5.56 births per woman. I figure that's a pretty big range. If you know anything about how many kids that you would have at home, I feel like that's a very large difference between countries. Okay, so as I said, not super useful. Sometimes it's your only option. The next measure of spread we're going to work on is standard deviation. And in our problem, we are working with a sample of 10 countries. So we're going to work on sample standard deviation. And the symbol for that is S with a subscript of X. I call it S sub X. And population standard deviation is different, and we'll talk about that at a different time. But for now, we're going to call this sample standard deviation very specifically because my problem has a sample of 10 countries. And so I'm going to use the symbol S sub X. And to calculate standard deviation, there are 6 different steps. The first step is to find the mean. And in our case, the mean was 2.53. So we already have the first step done, which is great. Okay. Second step is to subtract the mean from all values. And what I've done, hopefully to make this a little bit easier, is I listed all 10 of my birth rate values in a column down the side. And I'm going to subtract the mean of 2.53 from each of these. Okay, so step 1, find the mean. Step 2, subtract the mean from all of your values. Step 3 is square your answers. Okay, so in this case, I am going to put parentheses around this and square. You can find your answers first and then square them if you want, but I'm going to do this in one step. Okay, so to find this first value, I'm going to say parenthesis 2.58 minus 2.53 squared, and that value is 0.0025. And I'm going to repeat this process for the way down, except for I did it before the video, so I'm just going to write down my calculations that I did beforehand for sake of time. This is a big one, 19.0096. Okay. So step 1, find the mean. Step 2, subtract the mean from all of your values. Step 3, square your answers. So parentheses squared. And then I wrote all of my answers down. Step 4 is add these numbers. I like to put like a plus here and a line underneath. And all of these numbers come out to be 24.75. Okay, step 5 is to divide by n minus 1. And let's define what n is. N is how many numbers you have. So in this case, I'll be dividing by 10 minus 1, which is 9. And I'm going to write that out. At this point, I'm actually going to take my calculations over here, and I'm going to talk about variance. Variance is the standard deviation squared. So you get the variance in the very last step before I'm actually going to square root to undo my squaring. You get the variance right before that very last step of square rooting. So standard deviation squared is the variance, and that is, in this case, 24.75 divided by 10 minus 1. 24.75 coming from adding all of these numbers together. Divide by the number of numbers you have minus 1. So 24.75 divided by 9. Okay, and then the last step to get standard deviation without the squared is to square root both sides. Which in this case is 1.66. Okay. I want to say a couple of facts about standard deviation and then interpret the standard deviation. First, what is standard deviation? So you did all of this beautiful calculating here and you got a number and you know how to follow the steps of the calculations, but what did you actually find? So that's what we need to talk about next. First, you need to know the bigger the standard deviation, the more spread out the numbers are. Standard deviation is a measure of how far apart your data set is. Our data set goes from 1.33 to 6.89. So the standard deviation is 1.66. I'll explain what that means in a minute. And I'm sure that you can tell standard deviation is not resistant to skew and outliers because look at this giant calculation of 19 right here when I use the 6.89. So clearly the calculation was affected by that outlier, possible outlier. I don't know, this might be a huge spoiler alert for later, but I'm assuming that you can probably tell it's an outlier. I tried to make it obvious. Okay. And when you're talking about standard deviation, you're going to be asked a lot of times, and a lot of times through the whole school year, you're going to be asked to interpret standard deviation. And what does it actually mean in the context of this particular problem? Okay. Our interpretation is going to start with the typical distance between each birth rate. So what I mean is each individual number in our data set, which represented a birth rate of a different country, the typical distance between each birth rate and the mean of 2.53 births per woman is 1.66 births per woman. Okay, so each one of those numbers in our data set is on average about 1.66 births per woman away from the mean, which is 2.53. So it's showing how much they vary on either side. And in this part, I am going to underline birth rate, the number for the mean, and the number for the standard deviation, because those are the values that will get switched out in each different interpretation and each context. So this will be the context of the problem. This will change from problem to problem, and this will change from problem to problem, but the rest of the sentence stays the same each time. I call this a recipe sentence because it's a recipe to fill in the blanks. By the end of the year, you'll have several or more than several, a few, a couple. Okay, we're in the last bit. This is the last part of the notes for this video. And the last thing we're going to talk about is interquartile range, or IQR. And interquartile range actually has a definition. The first thing I want to say is that all of us lazy people call it IQR. We don't necessarily say interquartile range, but that's what this stands for. The interquartile range is the middle middle 50% of a distribution. And this is the center of the measure of spread that goes with the center of median. So I don't know if you noticed, hopefully you noticed that in the standard deviation calculations, we use the mean. So standard deviation and the mean go together. Okay, but in interquartile range, we're going to use the median, which is why I was talking to you before about the different ways to find the median. So first thing we're going to do is talk about what these things mean. First, there's something called a 5-number summary, which is the min, quartile 1, median, quartile 3, and the maximum. And to talk about interquartile range, that is this part of the distribution, which is 25% between quartile 1 and the median, and 25% between the median and quartile 3. So the interquartile range is the middle 50%. And as you could imagine, there's also 25% between these, 25% between these, making a total of 100%. You can also think about quartiles being quarters, 100% divided into 4 sections, 25, 25, 25, and 25. Quartile 1 is the median, interestingly enough, of the numbers below the median. And specifically below, not below and including, fully below, underneath, not with the median, just completely below, less than, not less than or equal to. And then quartile 3 is the median of the numbers above the median. Again, strictly above, not above and equal to. Okay, so for our data set, I'm going to flip back to my data set being written out, and I'm going to use my red pen again to mark it. So here is my data set from before, where I have the median marked, and I'm going to cover up all of the values below the median. So I'm going to put my hand on the line of the median. Quartile 1 is going to be the number that is the median of these numbers. There are 5 numbers, so quartile 1 is 1.77, which is the 3rd number in. To find quartile 3, I'm going to put my hand over the data set below the median. There are 5 numbers, so quartile 3 is going to be the 3rd number, the middle number, which is 2.58. So my interquartile range is going to be 2.58 minus 1.77. Zero 0.81 births per woman. Okay, we're going to write 2 notes here. This will be the end of anything that you need to write. And then I'm going to show you very quickly how to find the median and the quartiles off of numbers, data sets with different values. But IQR is resistant to skew and outliers. That's because in my calculation, I did not use any numbers that were on the extreme, low extreme, or the high extreme. I only used values that were inside of the data set. And very important, I know I said this a bunch of times, but do not include the median when finding quartiles. And also do not worry about this stuff written down here because that's going to be for video 6. Okay, so the last thing I'm going to do is, and you can be done writing now, just watch. I have 2 data sets for you of different numbers, and I'm just going to very quickly show you how to find the median and quartiles when there are different size data sets other than 10. And I picked out these 2. This data set has 11 numbers. This one has 9. So they have a little bit of a different approach. This one has 11 numbers. That means that you'll have 5 numbers below the median and 5 numbers above the median. And the median is an actual number this time. It is the 6th number. Okay, then when you find the quartiles, when you find quartile 1, do not include the median. Only look at the numbers below, strictly below the median. And like the data set before, there's 5. So the middle number would be 23.8. And again, do not use the median when finding quartile 3. There's 5 numbers above the median. So quartile 3 would be the middle number, which is the 3rd number, which is 33.3. Okay, now we're going to talk about number 2, which has 9 numbers. And in this case, 4 numbers will be below the median and 4 numbers will be above the median. The median will be 8.5. Do not include the median when finding the quartiles. Notice that there's 4 numbers this time. So quartile 1 is going to be in between the first 2 and the second 2. And to get the quartile 1 number, you average these 2, which would be 7.75. And then there are 4 numbers above the median, and quartile 3 would be in between the second and third number. They're both 10, so the average of 10 and 10 is 10. So quartile 3 would be 10. So sometimes the median and quartiles are numbers in the value. Sometimes they're averages between numbers in the value. Thank you so much for watching, and I'll see you in the next one.